Great.
Thanks. Am I unmuted now? Good to go. All right. So I'm going to start my little stopwatch here so we know how long we've been taking. I'm Barbara Minsker, and I'm from the Department of Civil and Environmental Engineering. And we're the third case in Brown Dog, and we're kind of complicated because we actually have 3 faculty collaborating on this use case from different disciplines. And each of us has students. So in order for you to get a sense of the breadth of the use case, we're all going to take a spin through these slides and rotate out from one to the other. So our focus is on green infrastructure, but I should clarify that that's green stormwater infrastructure because that term is sometimes used in different ways. And how can we design green stormwater infrastructure in ways that promote both environmental and human health? So what is green stormwater infrastructure? Things like rain gardens, green roofs, bioswales, wetlands, even some ponds. If you live in Champaign, we have a lot of these ponds around that were actually built to manage stormwater, but are used for a lot of other purposes as well. So overall, the motivation of this use case is to try to understand how, a typical stormwater engineer would design one of these things and say, I want to be able to capture the first inch of rain that falls in any given storm. So I'm going to design this rain garden that'll capture that and then filter the water into the ground. But in fact, when you put green spaces into urban environments, you're affecting the larger ecosystem as well as a very local ecosystem, and you're affecting the people who live there as well as the people who pass through. And so how can we help engineers and landscape architects and other designers who get involved in designing these things to understand the broader implications of how one should design these systems? So to do that, I'm going to get over here to the mouse, we've got to involve stakeholders as well, because we're changing what people's neighborhoods might look like. And they have a lot of opinions about what they want their neighborhood to look like, and if we don't involve them in the process, then it's probably not going to be successful. If we're putting some plants in, they might mow them down if they don't like them and they think they look too weedy, or they might just pull them out and replace them with something else. Then also considering the stormwater requirements. So we're thinking about green infrastructure design from 3 perspectives in this project. One is hydrologic modeling, which is the stormwater piece, the cost piece, which is always important in any kind of project, and the human well-being. And we're creating models of these pieces that we'll then use to create different rankings and then come up with designs and look at the trade-offs amongst how we address people's needs versus the environment's needs, and also the cost issues. So the specific questions getting down to what we call the sub-use cases, so the different aspects of this. So in my research group, we're focused more on the design questions of how do we pull all these pieces together into looking at how we do design. And I should say that green infrastructure has other benefits that we're not considering in this project, things like urban heat island effects or air pollution and other kinds of impacts from putting green spaces in. That's something we're hoping to do on another project and bring in those other facets. But for right now, we're focusing just on these pieces. So my group is sort of the synthesis group, and then Professor Schmidt's group is focused on the stormwater piece, and then Professor Sullivan's group, he's from landscape architecture, focused more on the social dimensions of what effect is this having on the people. And then my group is working with him to figure out how do we actually put that into a model and something that we can quantify to help guide a design framework. So some of the fundamental questions that Professor Sullivan's group is interested in is what kinds of designs and types of green infrastructure do people actually prefer? What is the relationship between having green space there Is it nearby? Are you seeing it? And psychological well-being. What effect does it have that there's a green space when I walk down the street versus there isn't one? And how can we predict the impacts? So this is where my group's getting involved with this question of we haven't typically been able to do prediction where we have some new design and we want to predict how well people will like it so that we can sort through a lot of designs very quickly and come up with ones that we think people might like fairly well and then show them things that seem promising rather than just wildly creating new things that they might hate. And then lastly, Professor Schmidt's group is focusing more on the green infrastructure predictions of their performance on stormwater and thinking about spatial scale and what kinds of models are more accurate at different scales. Because when you're working with stormwater, the scales go from the very small scale. When you put a rain garden in, it's maybe the size of one or two of these tables. It can be quite small. So you actually have changes happening at that scale. That stormwater then goes into a river and down that river, and it can affect the watersheds at the scales of 40% of the United States is the largest watershed. So the outlet from that takes our stormwater down into the Gulf of Mexico and has impacts down there from what we do here. And that's true in other places in the country as well. So how do we think about those scales? Okay, so I'm up now to hand off to Tom. And I'm not going to try and say Tom's last name, but maybe you can do that for us. And Tom is Professor Sullivan's graduate student, and he's going to tell you a little more detail on the research context for his part of the research, or his group's part of the research.
Right. Thank you, Professor Minsker. So good afternoon, everyone. My name is Pongsakorn Tam Supakit Paisaran, or Tam, and I'm Professor Sullivan's student in landscape architecture. So there are several contexts that we are looking in this research, and in our lab there are two main studies that we are going to speak about. First of all, high school stress. Well, of course, you guys have been through high school. You can remember how stressful it was. Not only that your body changed, you have to handle coursework and your friends and everything. And it can be overwhelming. And it's not just guesswork. We did some research and found out that more than 50% of students score their stressful experience from 4 to 7 in the past the past month, and also the past school year. So now, we learned that nature has a prescription for stress relief and to relieve mental fatigue. And we have this lovely study that conducted by our lab, our researchers sitting right in front, about how 15 minutes break can really improve your test score if you spend that 15 minutes looking out the window to a nature scene such as trees and gardens. And now our lab is working on trying to figure out if the context around the schools and the home of that teenager's lifestyle really impact their physiological and psychological well-being and their test performance. And now we know that the trees are really impacting physiological response. What we don't know is that our human also evolved to react to a certain kind of green stormwater infrastructure. Would rain gardens and bioswales with all its stranger designs impact human psychologically, physiologically, the same way or slightly different than with the tree rows, the street tree, and the neighborhood trees? And how different is that, or how can we put that into consideration when we design? So, however, in terms of the green infrastructure as a system, we might have some idea which Ankit would be presenting to us.
Before Ankit jumps in, Bill, did you want to add anything? Okay, go ahead.
Thank you, Tom. I'm Ankit. Good afternoon, everyone. I'm working with Professor Minsker, and my aim is to build a model, GI model, to quantify these human aspect of green infrastructures, basically social aspect of green infrastructure. So you see here an infograph which says that what people on social media saying about green infrastructure. What are their sentiments associated with green infrastructure? So this is the data from Twitter, and this is for the city of Chicago. People who are tweeting from city of Chicago with hashtag green infrastructure, we see some positive sentiments associated with green infrastructure, which makes us believe that the theory and the fundamentals, what we as an engineer and landscape believe in, people are also talking about it. So in order to build a model which would predict these human aspects, human preferences, and human health, we are thinking of using image mining and text mining approach to build this model. So in this slide, you see that there are two figures. On your left, you see an image with low preference. On your right, you see an image with high preference. The difference is there are more trees in the high preference setting. So the theory suggests that adding more trees, there's a limit that you can add trees, which would be preferred by people living in that neighborhood. So this is the framework we have come up with. On the left, this is the framework for image preference model, image-based machine learning model, which we have done some prototype of work, and we have got some results which are decent to prove that it's working. So here we have the images, green infrastructure images with ratings of how people like it on a scale of 1 to 5. And we extract image features using different 4 computer vision algorithms which maps human preferences through the study. And we built a supervised machine learning algorithm, which is an ensemble machine learning algorithm we are working on, adaptive boosting, and predict these rating on a scale of 1 to 5, 1 being worst and 5 being the best. On your right-hand side, there's another framework which we have come up with. This is still an initial stage. So it's for predicting human health, how human health is associated with green infrastructure and human preferences. There's a difference in human preferences and human health. So we are basically looking for text mining approach. This is a typical sentiment analysis. We will be using natural language toolkit from Python to do some feature mapping of those sentiments, keywords like blood pressure, asthmatic, stress, anxiety, those kind of feature extraction. Sorry, I think I'll let Sun Young to present hydrological aspect.
Yeah, so what we're trying to do here now is predict the effect that the green infrastructure will have on the people, which no one has ever done before. And so we have these nice hydrologic models, which Sun Young will be talking about, where we've been doing that kind of prediction for a long time. But we haven't tried to predict the effects on people, and using all these different kinds of tools to figure out how to make that prediction. We're still figuring out what tools will work best. And then we'll put those pieces together. So go ahead, talk.
Thank you, Professor Minsker. I'm Sun Young Park, and a grad student of Professor Schmidt. And my research topic is modeling hydrologic performance of green infrastructure. And I would like to introduce a research context as a use case, starting from these figures. Most of you already know, over the last century, urbanization has contributed to expansion of impervious area. So urban water systems have significantly decreased infiltration and evapotranspiration, and increased steam water velocity and increased flood risk. So these problems have brought attention to green infrastructure in urban area to replace or supplement conventional stormwater management practices and also create a more sustainable urban water system. But despite the increasing attention to green infrastructure, currently available urban design tools cannot integrate the site-scale design decisions. This site-scale design decision with the catchment scale impact of green infrastructure. And also, design guidelines provide the site-specific criteria with only discussion of qualitative impact of green infrastructure at the catchment scale. We also typically use this type of site-scale design tools or catchment scale lumped parameter stormwater models such as SWIM or HEC-HMS that do not represent the detailed site-specific process of multiple green infrastructure. Furthermore, most of these models can only deal with the surface runoff without coupling with the groundwater or vegetation. So, however, this approach cannot incorporate the dynamics or kinematics of fluors or biogeochemical process or subsurface flow response. So consideration of ecological services in green infrastructure design requires an integrated ecosystem approach with the continuous and distributed hydrologic representation. So therefore, we will create an integrated modeling system evaluating holistic impact of green infrastructure from field to neighborhood to catchment scale by coupling numerical models at the different scales. And these models eventually will be coupled with the human preference, which is previously presented by Ankit, with human preference and health or ecological to assess design trade-off. So the visualizations of green infrastructure will need to be translated into modeling parameters for different hydrologic models at the different scale. So now I would like to ask Professor Schmidt to explain how Brown Dog works for our research with the brief summary of our presentation.
Thank you, Sonia. I'm Art Schmidt. I'm a professor of civil and environmental engineering, and as an engineer, I know how to build this. I know how to design it. It's going to work like it. And that's why we need Professor Sullivan and the landscape architects, is we may know how to make it work, but it may very often be ugly. And this last bullet here really is one of the key parts. We do have these spatial issues. As an engineer, we're very often working at a sewer shed or even a bigger catchment watershed scale. And as long as we get the water quality benefits, the stormwater benefits, we've done our job. And yet now we're looking, what about these other benefits, the human preference, the human well-being? And with the tools that are being developed, how can we now take this where we're looking at that street that Ankit showed? And we have different vegetation, and the different vegetation will have different root depths. and different hydrologic behaviors, and it's at this very small scale. And so really one of the big issues is how do we take these visualizations, these human preference things, and start to deal with some of the other issues. We have up here a little bit of green connectivity. There is a difference between scattering these things just randomly throughout a neighborhood and producing green corridors, both in the hydrologic behavior and possibly in the human preference and well-being. So how can we start to take these data and these non-engineering data sets on preference, on here's an image of something, and turn it into something that we can now, both from the very small green infrastructure scale all the way up to the watershed scale, start to talk about what's going to happen. At the same time, there's challenges of all the data and the very different formats and repositories for data in these urban environments. So putting these models together, compiling the data and coming up with something useful is where Brown Dog's going to come in. A little later on, we'll talk about some of the tools that we'll use for that. But I think we've got a few more, so I better be quiet here.
Thanks, Art. So in terms of terminology, when they say catchment and watershed, that's the same thing. And what it means is when the rain falls, if all the land that drains to the same river, that's a watershed or a catchment. So that's the largest scale that we're looking at here. So that's a little more about the research context. And then the next piece we're going to talk about is what does our data look like as we're trying to do this. And as you can imagine, looking at all these different dimensions of the human side as well as the ecological and the engineered system, we've got quite a wide variety of data sets. Now, Ankit will tell us about those.
Yeah, so as Professor Schmidt and Professor Minsker mentioned, we're dealing with varied kind of data. Modeling a GI green infrastructure designs is definitely a data-intensive task, and that's why we see a huge potential of Brown Dog services here. So here we have sort of a cloud of data, preliminary kind of data we are working with currently in all three sub-use cases. We have image data, RGB images. We have video data for human preferences, which is itself an unstructured data. We have data streamed online through APIs like Google Street View API, we have Twitter API, and we do have a text data mined through scraping blogs and comments, what people are saying about green infrastructure. They have positive opinions or negative. We have psychological data, which Professor Sullivan's lab is collecting. These are physiological measures, which has like blood pressure, heart rate, and skin temperature kind of things, which falls on the category of time and frequency domain data. For the hydrological model that the Schmidt group is doing is LiDAR data, soil map, GIS data. We also have GPS data to track the position of a user moving in a neighborhood. We have remote sense data, satellite image data. So they are definitely heterogeneous kind of data which we will be dealing with, and there will be more, which we are not aware of at this point. And so there's definitely a huge potential of Brown Dog. How could we leverage the service of Brown Dog to build this green infrastructure model? So I'll ask Tom to present what are the tools we would be using to analyze these models.
Thank you, Ankit. So in terms of tools, we have the tools that can test different kind of preference, health, and performance of green infrastructure. So one of the tools that can be helpful is that we have, in previous study, a lot of text that come from people viewing a video of a neighborhood with different levels of greenness in street tree. And it's an open narrative questionnaires, which means each person has written a paragraph describing how they feel. So now with Brown Dog tool, it can use the sentiment analysis to come in and start taking our data and analyze the relationship between what they like or don't like about this green infrastructure area. And to take that another step, in our lab, we have this method where a postdoc student has created this application. People can take a photograph and can comment on it as like Facebook or social media style, but it also take some of the coordinate system into it. So not only that this one can be analyzed in terms of sentiment analysis, but it can also, take the coordinate system and create a map to see the density of where people take photograph and whether they like it or not. Another tool that Brown Dog could help is the statistical tool. So currently we are using the SPSS functions to run our statistics in Landscape Architecture Lab. And sometimes the problem we face is we have to run several data. For example, this study, we try to find different relationships in different group of data, and we end up having to run 18 times to create all the graph for statistic for interpretation. Now, when I talk to the Brown Dog programmer, she says what she could do is create this automatic set of codes where it run the more common selections of this data interpretation for you. So if you enter in your spreadsheet or statistical data, already it had some basic statistical analysis done for each variables and how they relate to each other. And you as the user can make another input and customize that later. So basically it can make a more user-friendly results and eliminate some hard work in statistical analysis for us. And this one is a little tricky and unconventional for Brown Dog typical use, but what we can do for the questionnaire is that we have a big set of photographs that we have collected. And what Brown Dog data conversion and extraction could do is that it can analyze this picture based on the preference score we give and create a questionnaire where it distributes the preference score evenly. And these questionnaires, when we give to people, can spread out and randomize this photograph that we took. So every photograph got graded by the future surveys. All right. So we also have other tools for different studies, such as health data. Currently, our researcher is dealing with the GPS system. They track down some high school students and have them report where they are and how close they are to green infrastructure. So it requires a lot of tedious data cleaning and classifying. They have to look at the satellite image and then translate it to see how dense these green infrastructure are, how land cover would affect their activities, and translate all these tract and urban tree canopy together to find the axis score and see how it works. All right, so the next set of tool would be the performance, which I would give to Professor Schmidt.
Yeah, and while he's coming up, we've got a lot of ideas for tools for this use case, and part of what we're still in the early stages of the project, so figuring out which of these tools would be useful for other kinds of applications, not just for green infrastructure. Do you have data sets, maybe in a completely different domain, where the same kind of tool might be helpful? That will help to set the priorities of which of these tools are we going to do, because there's too many for us to undertake on this project.
Some tools for the modeling of the green infrastructure. Determining the basic model parameters. We have the different scales. There's often a lot of data out there, but every municipality is different. They use different software packages, or perhaps not, perhaps paper maps to store their data. Things are done at different scales. We're dealing both with vertical scaling, soil column, soil data. We may have some soil maps in a GIS format. We may just have borings that were done when a construction project was going to be done, or a well was drilled and they've kept records of the soil borings. So taking these different data sets and turning them into our model parameters. Some places will have data sets describing these are impervious areas. We may have a GIS coverage of our roads. We may have to go back to aerial photographs and digitize, and how do we determine, is this a parking lot or a rooftop, or is it a pervious area? So we have issues like those that we have to deal with. It was mentioned earlier, model parameters, that a lot of communities have done model studies at the larger scale for their stormwater management. There's many different models out there, but some of the data that we need are embedded in these model input data sets. Very often these are public domain. But how do we take and translate from one model with different scales that we've discretized things in into the scale and the data that we need for the models that we're going to run? So a lot of these issues of coming up with the data archived in different municipalities, different GIS systems, paper copies into what we need, dealing with the scale, and then I mentioned earlier the tools that will take some of the GI preferences. We have a rain garden in a street view with a certain type of vegetation, and how will we turn that into the parameters geo-reference to put that green infrastructure in the model? So these are some of the things where we believe Brown Dog can be very helpful in us merging the engineers and the landscape planners, the social scientists to look at this complex system.
Thank you, Art. So that's our little dog and pony show for you. And if you have some questions or comments, we'd be glad to hear it. I think we have about 9 minutes left. No, 14 minutes left before our 45-minute allocation's up. Yeah.
There, can you hear me? Hi.
Great.
I'm super excited about all the brown dog use cases. This one happens to touch really closely on parallels with my research. And so first question, and maybe more of a comment and a request, which is on the rain garden photo and the sentiment analysis. You have put there a really key question on identifying tonality, because the tonality of this rain garden is a mess is a sentiment about that particular rain garden and not rain gardens in general, which is going to be a really tricky problem to solve. So woohoo, can't wait to see how you address that. Number two, this is the real first question, I guess. Sorry, I'll ask quickly. Are you leveraging other tools? I see that you're using the Python natural language, but are you also leveraging things like CI Shell and Sci2 out of Indiana at Bloomington and those other tools that are already out and open?
So as we are at initial stage of creating this text mining approach, and yeah, there are definitely other tools as you mentioned, and thanks for that. We are still exploring, and we have what we have done is some prototyping, if that works, for sentiment analysis for human health prediction. So NLTK was something which came up in my mind, and started doing digging into it, how it works and how it performs, because quite a validated tool to work with sentiment analysis. But yeah, definitely we are open to other tools as well in future.
Literally, Ankit, that little word cloud, he
Yeah.
made that yesterday.
Oh, okay.
So
we can compare
the
word
idea
clouds
came up
then.
like last week. Oh, we could do text mining. So he's been playing with it, but we haven't done anything
So the
serious
challenge
yet.
is how would we link human preferences rating with human health? They are two different things,
Yeah.
and the linking is something we are exploring with different techniques like text mining and image processing.
Great. I look forward to
It
talking
would be
with you.
great.
Thank you.
Maybe during the break we could chat a bit, and it sounds like you might have some ideas that would be helpful.
And one last question, and it's a Brown Dog specific question. Does Brown Dog assume we're all using HPC? Because once you start doing this on a desktop, it just takes too long.
So the idea is that it'll be backed by some sort of HPC resources. You won't have to. Right? This REST interface, these client applications are what you'll see, but the computational aspects of it, we'll take care of when they'll be in the back end. Yeah.
Yeah. So if HPC is needed, it'll be called and dealt with, and you won't have to. That's the beautiful world that we're all looking forward to. Yeah, question back there.
As I was listening to this, I was so struck with the ultimate goal of what you might be able to achieve if all your goals are met, and that is to obviously improve human health and happiness. And there's a tool that you can use where you can actually track zip codes by the driver's license and the BMI of the patient. So the BMI is expressed as the body mass index. So if you look, it's a public, I think you can you have to do a little work, but you can get into the driver's licenses, and they have the height and the weight of every individual, and then you can track the body mass index of the individual to your geographic area, which then is a very gross indicator of health. We know that the comorbidities of health increase as the weight and the body mass index increase. It's a poor man's method, but you already have all this geospatial business going on, and it would be such a simple layer to put on, which would, I think, give you a lot of powerful predictive.
Yeah, that's a great idea. The challenge is to figure out, because so many other things affect human health, how do you figure out how much the green infrastructure itself is affecting human health? And we raised the question of connectivity, right? So if we're putting rain gardens in little patches around the city versus putting a greenway down the city, well, with the greenway, people can bike. If you've ever gone out to a greenway in cities, you'll see people out there biking and walking and doing all kinds of exercise. So if you had a greenway nearby, that might, bring the weight down of the people who are in that area. But how could you separate that from a lot of other facets? So then we have to.
But you can,
this is
you
where
can
we
do
call
that.
on Bill.
You can do that. You can do that, and what you need is a large sample size, so that you can statistically control all these other
Control the other
covariates.
stuff.
And
Yep.
so it's not that difficult. It's actually
But you
people
have
in
to have
public
enough
health.
data,
People
right?
in public health do this all the time, and we use their methodologies. But it requires a large data set so that you can actually control these things.
And in terms of the green infrastructure data sets that we have, where we've looked at images and how well do people like these, and then how do they respond to these actual images, those data sets are not really big. So how do we tie those together with the public health data sets? Those are some of the research questions that we're trying to figure out. And wonderful suggestions. So we'd love to talk with both of you a little bit more later. Yeah.
I was just curious if there's been any thought about taking, translating individual GPS tracks. I'm sorry. The point about translating individual GPS tracks. But so, are you talking about aggregating data from people's? Essentially they have their cell phones track them wherever they go. Some people have, particular apps that track them when they run or do exercising. It seems like that could be overlaid.
Hong Ying, do you want to answer this one?
Turn your mic on.
Or do you want me to?
Well,
Just tell them what you're doing with those students.
Yes, we're not aggregating those data. We're looking at individual level access to greenness. And
but I think there's one piece that's missing here, which is the idea is you hook the students up with some instrumentation and GPS monitor and other things that measure their physiological response. And then you send them out in the city and see where they go and what kind of green infrastructure they go past.
Yeah, so
and that's the data she's talking
about.
So
we're matching individual level access, like GPS tracks, with individual level psychological well-being. We can use GPS device as well as mobile phone apps for the tracking purpose.